Okay. In this lesson, I want to discuss the reactions of acids. The first three reactions are classified as neutralization reactions. The fourth reaction is going to be classified as a redox reaction. This we did in grade 9. Last time we did this was in grade 9. We might have quickly run through it in grade 10, but we didn't really spend a lot of time on it. So this year we're revising grade 9 work, doing grade 11 calculations, and then I'll also touch on the grade 12 work. Because there is only one thing that is added in grade 12. After pH calculations, there is one more thing that is added. Okay. So the first reaction is when an acid reacts with a base. What will be formed? A salt and water will be formed. Okay, so this is a neutralization reaction. Yes.
Will you ever get a reverse of this reaction?
Not this one, no. There is another one inside this one that could be a reverse reaction.
So there will never be from water plus salt to acid?
No. A water plus salt will be a solution. If the salt is soluble in the water, you won't see a precipitate. If the salt is insoluble in water, you'll see a precipitate. So we can talk, precipitate is the solid that comes out of the solution. Okay. Choose your acid.
Hydrochloric acid.
Okay. No, it's fine. We can start with hydrochloric acid. And we can do base. Choose your base.
Magnesium, sodium hydroxide.
Sodium hydroxide, fine. So it's the first ones that we did when you were in grade 9. And the salt that will form would be sodium, chloride, and water. We need to make sure that the solution that the equation is balanced, and that would be aqueous solution. Aqueous solution. Is sodium chloride soluble in water? Yes, it is. So that would be aqueous solution, and water will be the liquid. Yes. Yes.
Is there a fixed way of knowing how the elements combine? Because what I normally do is I kind of just guess, and basically like what I'm seeing is that we break up the molecules and then we like swap them around. So that's what you always do.
Yeah, a salt is always a metal, non-metal bond. So you'll have a cation, anion bond. That's a salt. That's the definition of salt.
So isn't
HCl is an acid. No, it doesn't. But when it is dissolved in water, it ionizes. That's where you are thinking. The solution of HCl has ionized, and that is the reversible part, into H plus and Cl negative. So technically you're thinking of HCl as an ionic compound, but it isn't. It's a molecular compound that ionizes. Me putting there AQ means that. And I knowing that it's a strong acid tells me that there will be hydrogen ions and chloride ions in there. You're not fooling me. Did I answer your question?
Yes, sir.
And sodium is in group 1 and hydroxide is OH negative. So there's one negative charge on the hydroxide and a 1 plus charge on the sodium. So this is an ionic compound. This one is ionic. But it's not classified as a salt.
Well, that
It's
depends-
classified as a base.
Well, that depends on the difference in polarity.
You're really going deep. It depends on how it is formed. The sodium hydroxide.
Is it not a basic salt?
I want to go into that soon. I'll tell you something. This is a neutral salt that will form. So the pH of this solution would be 7. And I don't have to guess it. If you have a strong acid, neutralized by a strong base, the pH of the salt solution is 7.
Does it not depend on how many moles of the strong acid or strong base that you use?
It would, because what I'm looking at is a complete neutralization. So there's nothing in excess.
So,
But
like,
we'll talk about the ones where there is excess. This is if there's nothing in excess. So you've added a perfect amount of hydrogen chloride to the perfect amount of sodium hydroxide to neutralize the solution.
So, ma'am, these, the 3 elements are all dissolved in water because they're too strong to be by themselves.
No, they are solutions. You're thinking too deep now. The acid ionizes in water, so it forms the H plus and the Cl negative ions in the water. They are there. The sodium hydroxide will also be freed, so you'll have sodium ions and you'll have hydroxide ions. Sodium hydroxide will also be sodium ions and hydroxide ions. Now in this mixture of ions, what will draw to one another? The sodium and the chloride will draw together. They will form sodium chloride. If you allow the water to evaporate, the crystals will be there.
So, ma'am, you said sodium hydroxide is ionic, right?
Yes.
But then when I look, they have, it's like the same thing. So why isn't hydrochloric acid?
Here I'm representing the sodium hydroxide by using its formula. There I'm representing the sodium hydroxide by using its formula. Here I'm representing the hydrogen chloride by using its formula. What happens in water? You don't have ions here. You've got a covalent, a polar covalent bond between hydrogen and chlorine because they are non-metal atoms. but mix it with water and a dative covalent bond will be formed. I'm not representing the oxonium there, but it's there. So I could represent that reaction like this. HCl plus H2O, and now you'll see that there is a change. H3O plus forms and Cl negative. Okay. Right? Are you happy?
Yes.
So this is new. A strong acid and a strong base will neutralize to form a solution that has a pH of 7. And up to now in your life, you have always thought that when an acid neutralizes a base, the pH will be 7. That was your idea of neutralized. Your idea of being neutral means the pH is 7. This year I'm going to teach you that it's not always that way.
Would it be closer to 7?
No?
It depends. Okay.
Yeah.
So it might be.
Don't worry about it. We'll get there. I need to also talk to you about things called indicators. Indicators are chemical substances that are classified as weak acids, and they change color depending on the pH of the solution. Yes. Pardon? Indicators changes color because of a change in the concentration of hydrogen ions or the concentration of hydroxide ions in a solution.
All this is still neutralization, no?
All this is still neutralization. I'm just bringing in the choice of indicator that you will use if you choose to neutralize an acid by a base. And in this case, we've got a strong acid neutralizing a strong base, and the pH of that solution will be 7. Okay. We have different indicators. Yes. Bromothymol blue and litmus are two indicators. They change color when the pH reaches 7.
7.2 to be exact.
Okay, it's fine. It's not a problem. It's around 7. Okay. They do not use universal indicator in a reaction like this because turquoise and green confuses our eyes.
Yes.
So they will use an indicator that's got one color at a pH less than 7 and another color at a pH higher than 7. Not a possibility of mixtures.
Ma'am, why not just use a digital indicator?
I wanted to buy one, but they're very expensive and they don't last long. In a neutralization where strong acid is neutralized by strong base, we can use bromothymol blue is the more commonly used one. Litmus, I found after doing experiments with liquid litmus that it takes some time for the color to change. So it is much quicker to use litmus paper than what it is to use litmus solution. So your more practical one to use is your bromothymol blue. So when you have to do a titration using that, is what you'll do. Yeah. Yes.
That's a solution, right?
Bromoethanol blue solution, yes. So what is the color in an acid?
Red.
It is yellow
And red.
in an acid and blue in a base.
Oh,
That's
So there will be a definite change in color, either from yellow to blue or from blue to yellow. Okay. My next question is, what happens to pH when you add the acid to the base?
When you add the acid to the base,
When you add the acid to the base, the pH will decrease. That is something important to note. Note, when acid is added to base, the pH of base decreases.
Obviously.
Yes. And when the base is added to the acid, the pH will
The pH of the what?
so now does that mean when an acid is added to a base,
the pH decreases.
concentration of hydrogen increases?
Yes. If you want to say it that way. We're going to use a strong acid and a weak base.
So with some like this up, right? So this is just reactions of acids. And then the other one, the titration, works with the conjugated story. Is the titration that works with it.
I'm just looking at neutralization now. Some of them can be, so we're not looking at conjugate acid base now. You could, but I'm not looking at it now.
Would you give us like all the values?
I can't answer that question.
Oh man.
She wants it to be a dry. She wants it to be salt.
So now this salt will be slightly acidic, right?
Wait now. Okay. So here, strong acid, sulfuric acid. And a weak base is something like ammonia. Now, technically ammonia, when it is in a solution, it's ammonium hydroxide.
Why?
It is, because it reacts with the water. So if you have these two acids making contact, what will the salt be?
I have no idea.
NH4.
NH4. SO4.
Yes. And
I have a problem with the formula here.
Isn't it brackets 2?
Ammonium,
H2.
2 ammoniums. Yes, Tina?
Ma'am, I wanted to ask, would this still be a neutralization reaction?
Yes, it is. Strong acid, weak base, still neutralization reaction.
Does it change if you put the sulfate next to the ammonium?
They don't do that, so. Okay, can we balance this reaction equation?
Yes, we can.
What must we do to balance it?
got 10 hydrogens on the right.
Yeah, so we need to do something here to balance it.
First day,
Can't you times the H2SO4 by 2? Then times that whole thing on the right is by 2. And then times the NH3 by a few.
Okay, fine. 4. Will it work though?
Let's calculate.
Okay, let's see quickly.
There's 4
Otherwise I
ends.
need to
There's
fix.
also 4 ends.
There are 12 and 16 H's. Ah, you know what? I think this must be ammonium hydroxide. Let's change it to ammonium hydroxide so that it will work out. It's not going to work. Okay. So it's a thumbsuck example. So let's see.
Are we still going to use the
Ammo-
H2SO4?
Yeah, H2SO4 is still a strong acid, and like I said at the start, actually the ammonia solution is ammonium hydroxide. The moment your ammonia gets in contact with water, it makes ammonium hydroxide. So I think it will work out now. What do you say, Marcus?
Yeah.
We need 2 ammoniums on this side. Then the sulfates are balanced, the ammoniums are balanced. Now we just need to check the waters. 2, 4 hydrogens, so there should be 2 waters. Lesedi, Tina,
Is it still going to stay NH4SO4?
Yep. will still stay there. Alright, now next period we'll start here and look at the neutralization of this.